Good day, everyone. Welcome to my YouTube channel. As you all know, I am Ernest Okorosa, your motivator and teacher, and I'll be taking you briefly on chemistry today. And before we proceed, please do well to subscribe to my YouTube channel, hit the like button, and turn on the notification bell. For my regular students, for today's topic, we shall be focusing on a very vital aspect in chemistry that has to do with chemical equations, specifically balancing chemical equations. How to balance chemical equation. Balancing chemical equations. Now, this is a very vital aspect in chemistry as a science student that you students have some sort of difficulty in understanding. And many times students consider the fact that balancing chemical equations could be so difficult and tactical at the same time. So I want to break it down for us to understand that it is a very simple and easy task. Just give me your time, you'll get the best of it. Now, as an introduction, chemical equations, we have what we call chemical reactions. Chemical reactions are simply put on paper in form of chemical equations. As an example, let us consider the reaction. Consider the reaction A plus 2B giving us 2C plus 3D. Now, first of all, you can see an arrow, a forward arrow. It's called we call this an irreversible reaction. This is a reaction, it's a chemical reaction, but the arrow is called an irreversible reaction. It is known as an irreversible reaction because the reaction can only move in the forward direction. Now, on the left hand side, we have A plus 2B. A plus 2B is the reactant, while on the right hand side, we have 2C plus 3D. We call this the product. The reactant side, product side. So A reacts with 2B to give us 2C plus D. Now, it is vital for us to note that there is always a number in front of the letters. In this case, we have a 1 here present. So we interpret this as 1 mole of A reacting with 2 moles of B to give us 2 moles of C and 3 moles of D. So the numbers in front are known as the moles. We call them the moles. And many times we could have subscripts attached to our elements, always found at the base. For example, let me add a 2 here. In this case, we have a 2 here, so this makes D2. It makes it a molecule. So many times when we balance equations, we do not tamper with the subscript. Whenever you see a subscript, you don't tamper with it. So these are basic rules that you need to understand during balancing of chemical reactions. So you don't touch the subscript, because if you do, it simply means that you have violated the law of conservation of mass that states that matter can neither be created nor destroyed, but can be transformed from one form to another. So altering the subscript simply means that you have created or you have destroyed matter, which goes against that law. That's the law of conservation of mass. So it is vital for us to take note of that. Now, if we are to go practical, let's look at some examples on how to balance chemical equations, then also the procedures that guides balancing chemical equation. So let's take some examples and see how it goes. Like example, consider the combustion of ammonia gas in air. So let's write the simple equation to describe this statement. Now ammonia is a gas, NH3 is a formula in the gaseous state. It is being combusted with air. So air in this case is oxygen gas. Now when both react, we get NO, nitrogen monoxide, and water is evolved. This is a simple reaction. It's called a chemical reaction. So how do we balance such a reaction? It is very easy. Now the rules in balancing chemical reactions or chemical equations: first of all, when you're given an equation, you have to compare what you have on the reactant side and that of the product side. Do an atom to atom count for both sides, for the reactant and that of the product. Remember, do not alter subscripts. Do not alter subscript, because doing that means you have created or destroyed matter, which goes against the law of conservation of mass. And then after which you compare and ensure that what is on the right hand side is also the same as what is on the left hand side. So back to our example. Considering the combustion of ammonia gas in air, we have the product as nitrogen monoxide and water. So step 1, we have to do an atom check. Let's see. Remember, both of these are the reactants, while both of these are the products. So the reactants gives us the product. So let's do an atom to atom count for the reactants and the products. Remember, do not alter or change subscripts. Subscripts are H3, C3 here, C2 here, 2 here. You don't touch these subscripts. You only impute numbers in front, which are the moles, like I said earlier. So let's compare nitrogen. Nitrogen on the left hand side, we have 1. Nitrogen on the right hand side, we have 1. So it is balanced. Hydrogen here, we have 3. Hydrogen here, we have 2. So there is a lapse. It means it is not balanced. 3 hydrogen, 2 hydrogen. So we have to alter by using numbers. So permit me to do this. NH3 plus O2 giving us NO plus H2O. So I have 1, 1, 3 here, 2 here. So I would love to introduce a 2 here so that I can introduce a 3 here. What have I done? What does it mean? It means I have 2 nitrogen, 1 nitrogen. So permit me to introduce another 2 here so that it balances. 2 nitrogen, 2 nitrogen. So nitrogen is balanced. The 2 comprises of everything here. So 2 times 3 give me 6 hydrogen. So I have 6 hydrogen here. 3 times 2 is 6. So 6 hydrogen here, 6 hydrogen here is balanced. Now let's go to oxygen. Oxygen here is 2. Oxygen here is 2. Oxygen here is 3. So 2 plus 3 is 5. While on the left hand side we have just 2. So 2 against 5 is not balanced. So permit me to introduce a 5 here. Now let's do an atom check again. Two NH3 plus 5 O2 giving us 2 NO plus 3 H2O. 2 nitrogen, 2 nitrogen is balanced. 6 hydrogen, 6 hydrogen is balanced. 10 oxygen and 5 oxygen is not balanced. So what do? we have to alter something. So you think of a number that you can change. What if I decide to introduce a 4 here? It makes oxygen here 4, 3 making 7, but I still have 10 oxygen, 7 oxygen. And then I decide to make this a 6. So at the end of the day, I have 2NH3 plus 5O2 giving me 4NO plus 6H2O. Now let's check. 2 nitrogen here, 4 nitrogen here. So there's an issue. I'm going to make this 4. 4 nitrogen is balanced. 4 times 3 is 12. So I have 12 hydrogen. 6 times 2 is 12. So 12 hydrogen is balanced. And let's check for oxygen. 5 times 2, this is 10 oxygen. I have 4 here. I have 6 here. So 4 plus 6 is 10. So 10 oxygen is balanced. So at the end of the day, we have nitrogen 4 for each, hydrogen 12 for each, and oxygen 10 for each. So balanced equation at the end of the day gives us 4 moles of ammonia gas reacting with 5 moles of oxygen gas, giving us 4 moles of nitrogen monoxide and 6 moles of water. In all, you will notice that I have not altered the subscripts. You see them, they are fixed. You don't change them. But I've been able to play around with the numbers in front by changing these numbers to ensure that what I have on the left hand side counterbalances with what is on the right hand side. So let's do an atom check again. 4 nitrogen is balanced. 12 hydrogen is balanced. 10 oxygen, this is 4 here, this is 6 here. 4 plus 6 is 10. So 10 is balanced. So this is a balanced equation for the reaction between the combustion of ammonia in air. The second example we shall be looking at is a reaction that involves HCl reaction. Let's consider reaction of hydrochloric acid. Reaction of hydrochloric acid and calcium trioxocarbonate 4. Don't mind the name, it's just for you to trioxo simply means 3 oxygen, carbonate, it involves carbon. So now writing a simple chemical reaction, chemical equation on this, the HCl, we have HCl, hydrogen with chlorine in the aqueous phase, that's hydrochloric acid, combining with calcium trioxocarbonate, CaCO3, is a solid whitish powder, it's going to give us calcium chloride, solid, plus carbon 4 oxide as a gas, and H2O, carbon 4 oxide and water. So this is a simple equation showing the reaction between hydrochloric acid and calcium trioxocarbonate. So on the left hand side, remember we have the reactant, while on the right hand side we have the product. Don't forget your subscripts, you don't tamper with. You see them? You only impute numbers in front, which are called moles. So let's do an atom to atom count. On the left hand side we have hydrogen 1. On the right hand side, the product side, we have 2 hydrogen. So 1 hydrogen, 2 hydrogen, it is not balanced. So I'll have to add a 2 here. I'll add a 2 here. So it's going to give me, I'm going to have 2 HCl plus CaCO3, giving me CaCl2 plus CO2 plus H2O. 2 hydrogen is balanced. 2 chlorine, you see chlorine is balanced. Calcium on the left is 1, calcium is 1. Carbon is 1, carbon is 1. Oxygen is 3, oxygen is 2 here, 1 here, making 3. So it seems this is a simple and easy task. So let's still check. 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine, calcium 1, calcium 1, carbon 1, carbon 1, oxygen 3, oxygen 3. So inversely, it means that we haven't created or destroyed matter. We have a balanced chemical equation. So as I summarize, it is worthwhile to note that doing balancing chemical equations, most might be straightforward, most might be a little bit tactical. So it's all knowing what to do, and at the end you get the best of it. So feel free to send your comments, send your questions, and don't forget to like my video, subscribe, and do well to turn on the notification bell. Thank you so much and have a blessed day.